Hello, my amazing students. This is Mrs. A, and we're starting on 4.1, which is about polynomial functions and modeling. So the first thing we're going to do is problem number 7. And our instruction is to find the lead term, the coefficient, the degree, and the classification of the polynomial. And so when we look at this polynomial, we have to be very careful because it is not written in descending order of the variable. So the lead term is the highest degree term, and it's way over here. So x to the 4th is the lead term. Its lead coefficient is 1, and it is a degree 4 polynomial, and it is quartic because it is degree 4. So that was number 7 on 4.1. Okay, so number 15 on 4.1 again gives us one that is not in descending order. If we rework this one and put it in descending order, my lead term is going to be 0.1 x to the 7. Okay, and then would come the plus x to the 6, and finally the negative 3.5 x to the 4th. Okay, so I have to be careful to put it into its descending order of the variable form. And now I can see that it is an odd exponent on that lead term, my lead term, 0.1 x to the 7. And because it is a positive x to the 7 function, it should be coming in low and going out high. Remember, all of our odd functions come in low and go out high. Now this one, because it's x to the 7, it's going to probably have some squiggles in there, but it's going to eventually go out high. And that is the general shape. We determine that by the end behavior of our odd degreed function. Okay, so basically on this exercise, all we were doing was choosing a graph that looks kind of like this one, and the 4 graphs that they give me, they say A is an up and an up. It looks like that with some squiggles down here, and B is a down and a down, and those would definitely be even, wouldn't they? Because even functions with the even exponent are going to either both come in up and up or down and down if it's got a negative on the front. And then C was going to go down and up with a bunch of squiggles in the middle here. And this is the one that looks like what we have. And so C will be the answer for this one. And then D is the flip of this one. So the D is going to go down, up and then down. So that is not what we have there. Okay, so that was number 15. Number 18, they have a habit of not writing it in descending order. So we have f of x. When we rewrite it, f of x is negative x to the 5th, and then plus x cubed plus 2x. All right, so that's our descending order, and we have an odd exponent on our lead term, but we have a negative in the front. So now instead of going low to high, it's not going to go low to high. It's going to come high and end up low. And again, because it's a higher power, it could have some squiggles in here, but it's going to wind up high to low. And that one was D on the choices of that one. So that one was number 18. The answer should have been D. And we'll come back with a few more. Hello, my amazing students. This is Mrs. A, and I'm in the car, and my husband is driving. So here we are. We're talking about zeros and multiplicities of these functions. And so here's the first one we're going to work on. And this one is number 27, and it's we're on 4.1. Okay, so what we're going to do is, because this one is already factored for us, it's very easy for us to see the zeros, because the zeros are what is where we get the function going to 0. So if we had the function equaling 0, then we would set each one of these factors equal to 0, and we would get a 0 of the function. So x plus 3 is the factor, so negative 3 is the 0. But notice that we have negative 3 in there twice, so that's going to be negative 3 with a multiplicity of 2. And then we have another factor, x minus 1, which is going to be a 0 of 1, and it just has a single multiplicity. So negative 3 with a multiplicity of 2, and 1 is a single multiplicity. Now, because this thing here, this polynomial, is a cubic, and there is nothing in front of the x's to make it become negative, so we're going to have a classic cubic shape, which is going to go like this. All right, that's going to be our classic cubic. This one is going to pop at negative 3, and then it's going to go through 1. So we can give a rough graph of this function by putting in a negative 3 and a 1. Okay, and we know that it's going to come up, and so it's going to pop the x-axis at negative 3. It's going to come back down. We can find the y-intercept also, and it should be at negative 9. So at negative 9, we know we're going to go through the y-axis, and we're going to come back up. It's kind of hard to draw in the card, but it should look basically cubic there. So you can actually give a rough sketch just knowing the x-intercepts and the y-intercepts and the end behavior of the function. This next one that we have down here is going to be an x cubed, an x, but because it's a multiplicity of 2, it's going to be squared, and then an x. So this is an x to the 6th function, and since it's x to the 6th, it's going to be a w-shaped function. So its basic shape should be w, and because it has more of the roots, it's probably going to have some squiggles down there, but generally a basic w shape. So we have 0 with a multiplicity of 3 is a 0, and we have 1 with a multiplicity of 2, and negative 4 is a single 0. Okay, again, since this one had a multiplicity of 3, remember, if there's an odd multiplicity, it will go through the graph, and if it's an even multiplicity, it will pop the graph. So this one will pop, this one will go through, and this one will go through. Okay, so there is the second problem. So here's a closer picture of the first one, and the second one. Got to move my down a little bit. All right, so now we're going to do problem 41, and this one is not factored for us. So the very first thing we're going to have to do is factor this polynomial. So this is 4 terms, so we're going to factor it by grouping, and its lead term is a cubic. So it should have a cubic shape, but we're going to have to come up with the factors. So we're going to factor by grouping, and out of these first 2, I can pull out an x squared, and then I end up with a 2 minus 1, 2x minus 1, and then over here I'm going to pull out a negative 4, excuse me, and then I'm left with a 2x minus 1. Okay, so there's the factor halfway done. And so now I'm going to pull out the 2x minus 1, and I get an x squared minus 4. So now this is equal to f of x, but remember, we're not quite done yet, because this one right here will factor again. So we're going to get 2x minus 1, and then for this one, it's going to be an x plus 2, x minus 2, which is going to be f of x. And now to find the zeros of the function, I'm going to let the f of x equal 0, and I'm going to set each factor equal to 0. So I'm going to get here, x is equal to 1/2. x is equal to -2, and x is equal to 2. Okay, so we have 3 factors and 3 distinct zeros. There are no multiplicities on this one. Okay, so this one is cubic, and I have 3 zeros. So when I go to graph this one, I'm going to put my grid, and I've got x is -1/2 here. Excuse me, x is 1/2. X is a -2, so we'll put it about here. And x is a +2. And when I look at the graph, it was a 2x cubed. And so it's going to be positive. This thing, and our y-intercept was 4. Okay, I can see that from the graph if you look at it. The y-intercept is 4. The last thing on there. So, 1, 2, 3, 4. So I'm going to put my y-intercept up there. And since I know that it's cubic, it's going to have this kind of shape. So I'm just going to start here on the left. I'm going to come from down low. I'm going to come up and hit my y-intercept. I'm going to come down, curve, and up. So you can get a pretty decent little cubic shape there just by sticking the zeros and the y-intercept and knowing the end behavior of the graph. So that is the end of 41. Now we're doing 45. Okay, 45 also is not graphed for us. So we're going to have to factor it. So we got f of x is equal to x squared times x squared minus 2. Okay, well when I set each one equal to 0, I'm going to get x is equal to 0 with a multiplicity of 2. And then I've got x squared minus 2 is 0, so x squared equals 2. So x is going to be equal to plus or minus the square root of 2. And we use our square root property. Okay, so now we have 4 roots, but only 3 distinct roots. So we're going to have here at the x is 0, we're going to have a pop. So we're going to graph that here. So remember, when we have our grid, this is still 45 here. Put that over a little bit. So we have 0, but we have a multiplicity of 2. And then we have positive, the square root of 2, and negative, the square root of 2, are our zeros. So we're going to go through those 2, but we're going to pop this one. Now, if you remember, here's our original formula. It's a quartic, so it's going to be a W shape, and it's a positive quartic. So here's our points, and we've got to have an upward facing W. So it makes sense to me that it's going to come from up high, it's going to come low, it's going to pop the y-axis at the 0, it's going to come back down, and then it's going to go back up, and that should be a fairly good graph of the function. So again, here was your first board on 45. And the graph. All right, students, so this is the last problem we're going to do, and this one is 34 in the book, and I just picked this one because I wanted to graph a rather complicated one for you, so that we can talk about the roots and the multiplicities, or the zeros and the multiplicities. So we have a 0 at 0 with a multiplicity of 2. We have a 0 at -3 with a multiplicity of 2. We have a 0 at 4 with a single multiplicity, so just 1. And then we have a multiplicity of -1, a 0, -1 with a multiplicity of 4. Okay, so look at the function and see if you can see why I put each one of those zeros and multiplicities down. Okay, so now we're going to graph the function, and we're just going to do this right up now. This one, I had to count it up. It's a 9-degree polynomial. Because it's a 9-degree polynomial and the lead term is positive, we're going to have this classic shape, aren't we? That's what we should be doing. Now there's going to be a whole bunch more squiggles down here, but we should come in low and go out high. So when we're graphing this, we're going to put get a new board here. I'm going to put each one of these multiplicities on the graph. And so at 0, we have a multiplicity of 2. At -3, which we'll say is right there, we have a multiplicity of 2. This was an M2. And then at 4, which we'll put right there, we have a single 0. And then at -1, we have a multiplicity of 4. So this is a multiplicity 4. Okay, so as we're going to go through graphing this, since we know it's a 9-degree polynomial, we're going to start low, and at this first one, -3 has a multiplicity of 2. So we're going to pop that 0, not go through it. So we're going to come from low, we're going to pop that 0, and we're going to come down a little bit. Don't know how far. We would have to put some points in here. And then we've got to come back up here and touch this 0, which is at which one is that one? -1. This 0 at -1. And it has a multiplicity of 4, which is also an even multiplicity. So again, it's going to pop this axis, and then it's going to go back down again. Okay, and then we have a multiplicity 2 at 0. So that's an even multiplicity. We're going to pop that again and go back down. Now, when we're looking at this, back to the original function, okay, notice that we have, when we let x be 0, our whole function is 0. So there's no other, the y-intercept is 0. So that doesn't add points. We already have touched the 0 here. And then lastly, at 4, we just have a single multiplicity. a single root, 0. So now we're going to come down some distance. It could be way down, but we're going to come down a little bit. And then we have no more reasons to come down again, and that should be the graph, which was what we were expecting the graph to look like. Was generally cubic in shape, which is from down low to up high, but I have touched every one of the multiplicities that were even, and we went through the single 0. So that is the end of 4.1, and this is Mrs. A. May God bless your day.